This is the fourth of 5 videos going through the practice exam for 2016. This video covers questions 16 through to 20. Okay, looking at question 16. When a capacitor C discharges through a resistor R, the voltage V at any time t after the start is related to time t by this equation. V is equal to 12 multiplied by 1 minus e to the power of negative t divided by RC. The first part of this question, we want to make t the subject of this formula. So here we've got V is equal to 12 multiplied by 1 minus e to the power of negative t on RC. We're going to divide both sides by this 12. So here 1 minus e to the power of negative t on RC is therefore equal to V on 12. So I shouldn't have switched this over to this side, but if we switch it over to the other side, we end up with e to the power of negative t on RC is equal to 1 minus V on 12. So now we're looking, here we've got our exponential term and here our regular term. So if we take our natural logarithms of both sides, there. So here we end up with negative t divided by RC is equal to our natural logarithm of 1 minus V on 12. So here we're going to multiply both sides by RC, so here and by negative RC, we'll get rid of our negative term here. We end up with t is equal to negative RC multiplied by natural logarithm of 1 minus V on 12. So for part B, they've told us given RC is equal to 2, evaluate the time when V is equal to 6 volts. So we want our time is equal to negative RC is 2 multiplied by the natural logarithm of 1 minus here 6 on 12. So when we put this into our calculator, we're going to end up with 1.39 seconds. Okay, now looking at question 17. We're differentiating here and then simplifying as necessary. So here we've got our inverse sine function and here our u here is equal to 4x squared. So our y is equal to our inverse sine of u here. So here if we do dy on dx, so we go to our formula sheet. So we have this formula 11 from our formula sheet. So here our inverse sine of u is 1 on here the square root of 1 minus u squared du on dx. So here we'll work through. So here we need our du on dx. We have our u. Du on dx here is equal to 8x. So now we're going to end up with 1 on the square root of 1 minus u squared. So here 4x squared squared multiplied by this du on dx is 8x. So here we've got 1 on the square root of 1 minus 4 squared is 16. X squared, so 2 times 2 gives us 4. Here multiplied by 8x. So here 8x divided by the square root of 1 minus 16x to the power of 4. Now moving on to part B. So here we can see we've got a fraction and we've got x terms at the top and the bottom. So we're going to be using the quotient rule for this. So here we have number 5 is our quotient rule here. So here we know, well, this here is our u. This here is our v. So u is equal to 3x minus 4. Du on dx is therefore equal to 3. V is equal to 1 minus 2x. dv on dx becomes negative 2. So here our dy on dx therefore becomes v 1 minus 2x multiplied by our du on dx, which is 3, minus our u, which is here 3x minus 4 multiplied by dv on dx, which is negative 2. All divided by v squared, which is 1 minus 2x all squared. So here we get 3 minus 6x, and we've got minus multiplied by a minus here. So this just becomes 2 times here. So we get plus 2 times 3x is 6x, and 2 times negative 4 becomes negative 8 here on 1 minus 2x all squared. Here our 6x's disappear. 3 minus 8 gives us negative 5 on 1 minus 2x all squared. So now looking at our part C, we see we have a natural logarithm here. And there's two parts to this sort of equation. First of all, we've got to divide. So we can split this into two different parts. We can make it our natural logarithm of x squared plus 2 minus our natural logarithm of 2x minus 1. And then we're going to go to our formula sheet. So looking at our formula sheet here, for each of these, we're going to say, well, it's 1 on u multiplied by du on dx. So here for our first term, this is our u, and for our second term, this is our u. So here our dy on dx, here looking at our first term, we've got 1 on u, so 1 on x squared plus 2, multiplied by this du on dx here. So du on dx becomes 2x, minus here we've got 1 on 2x minus 1, multiplied by this du on dx, which becomes 2. So we get 2x on x squared plus 2 minus 2 on 2x minus 1. Okay, so looking at part D, we've got sine of x multiplied by cosine of x here. So it's going to bring together our differentiating our trigonometric functions as well as our product rule. Okay, so continuing on from here, we've got our sine of x times the cosine x. So we've got u times dv on dx. So our u and our v. So u times dv on dx is sine of x, and then we're differentiating our cosine of x becomes negative sine of x. And then here we've got our v, which is cosine of x, multiplied by du on dx. We differentiate sine of x and we get cosine of x. So here we're going to get negative sine squared x plus cosine squared x there. Okay, so moving on to question 18. We're wanting to differentiate implicitly and find our dy on dx. So we're differentiating each term independently. So here we've got 2x cubed d on dx times our x plus d on dx times our y cubed is equal to d on dx here of our 2xy. So here, this first one, only x terms involved and whole numbers, we end up with 6x squared. Our second term here is only x terms, that becomes 1. So these ones are nice and easy. Our third term, we have this y cubed. And so here, it becomes here, our d on dy of our y cubed multiplied by our dy on dx. So our dy's cancel out and we get d on dx there is equal to, and now we've got our product rule here. That's our u and that's our v. So here we're going to get our u, 2x, multiplied by here, our d on dx of our v, which is y, plus our v, which is y, multiplied by our d on dx of our u, which is our 2x. So continuing on, our 6x squared is nice and easy, 1 here. When we differentiate y with respect to y, we're going to get 3y squared multiplied by dy on dx. Then here we've got 2x, and then here we've got our d on dx of y. We can't do this. So here we're going to differentiate it with respect to y, and then multiply by dy on dx, plus our y times here, if we differentiate 2x with respect to x, we get 2. So we have 6x squared plus 1 plus 3y squared dy on dx is equal to 2x times 1 times dy on dx plus 2y. So we've got these two dy on dx terms. We're going to move those over onto the same side. Okay, so here we've got 3y squared dy on dx. Here minus 2x dy on dx. And on the other side we've got 2y minus 6x squared minus 1. So here we've got our dy on dx. We take it out the front. We've got 3y squared minus 2x is equal to 2y minus 6x squared minus 1. We divide both sides by this 3y squared minus 2x. We get dy on dx is equal to 2y minus 6x squared minus 1, all divided by 3y squared minus 2x. Okay, so now looking at question 20. We want to find the equation of the tangent to this curve here at x is equal to 0. So what we're going to do, our equation of the tangent we need to differentiate for. So here we're going to start our dy on dx here. And so here's our u. So we're bringing it down. We've got 2u to the power of 1 multiplied by our du on dx, which is 1. And then here our 2x becomes 2x e to the power of 2x. So here we've got here 2 times x minus 6 plus 2x e to the power of 2x. So this is here, and we're at x is equal to 0. At x is equal to 0, our dy on dx here is equal to 2 times 0 minus 6 plus 2 times 0 e to the power of 2 times 0. So here we've got this 0 term that's going to end up being 0, and here we've got minus 6 times 2 is minus 12. When x is equal to 0, if we substitute in to get our y, so at x is equal to 0, y is equal to 0 minus 6 squared plus e to the power of 2 times 0. So minus 6 squared becomes 36, and then anything to the power of 0 is 1. So here we've got 37. Then using our equation to find our equation of the line, we're going to say our y minus our y1 is equal to mx minus x1. So same equation that we use when we're finding our gradient, just rearranged. So we've got y minus our y here is 37 is equal to our gradient here, negative 12, multiplied by our x minus our x1, which is 0. So here y minus 37 is equal to negative 12x. So y is equal to 37 minus 12x.